So let's take a look at how completing the square plays into solving a quadratic equation along with the square root property. So what I'm going to do in this problem is I'm going to complete the square on this equation that I've got first. So the first thing I want to do is to move the constant to the other side, because that gives me something that looks kind of like the completing the square stuff that we had, right? We had a square term, and then we had a linear term, and then we had a plus blank. So I'm going to add a plus blank here so I can complete the square, make this a perfect square trinomial on the left-hand side. But unlike what we were doing in the expressions when we were just completing the square, this is an equation. So if I add a blank to one side, I need to add a blank to the other side as well. So now I'm going to fill in that blank. So I'm going to make this a perfect square trinomial by taking half of 8, which is 4, and squaring it, which is 16. And that's going to go in the blank, which means that number is also going to go in the blank on the other side. Now, this is now a perfect square trinomial. So we're going to factor that into the perfect square that it is. So this is going to be x plus 4. And remember, that number that's here is always half of that number. And then on the other side, we're going to combine 9 and 16, give me 25. Now this looks like one of those problems that we were solving with the square root property. So I'm going to take the square root of both sides. The square root of x plus 4, quantity squared, is x plus 4, as long as I put a plus or minus on the other side. Square root of 25 is 5. And then I'm going to solve by moving 4 to the other side. Then negative 4 plus 5 is 1. Negative 4 minus 5 is negative 9. So that's solving by completing the square and the square root property. Now, for the second example that I've got over here, there's one little thing we have to watch out for. The completing this square pattern, that half of the b squared goes in the blank, doesn't work unless the x squared coefficient is 1. And in this case, it's not. So if you ever have an x squared coefficient that is not 1 and you're asked to complete the square, you need to make it 1 before we start. So the easiest thing to do in problems like this is just to divide everything by that coefficient to make that x squared coefficient 1. So that's going to give me this. And now we're just going to proceed as normal. Let me make that a plus instead of a funky looking symbol. I'm going to move the constant to the other side, just like I did in the other problem. I'm going to add a blank to both sides. Now I'm going to complete the square. I'm going to take half of 3, which is 3 halves, and I'm going to square it. Now, yes, I could write that as 9/4 right here. There's a reason I'm sort of leaving it as 3 halves squared. You'll see that in a second. That's also what goes here. So this side factors, and the nice thing about leaving that 3 halves squared on the left-hand side is this is going to factor as x plus 3 halves. Remember, it's always half of that number that goes into the parentheses whenever you're completing the square. On the other side, this would be negative 7 halves plus 9/4. And at this point, I actually am going to do the math for that. So let's see, x plus 3 halves squared equals, and let's see, that would be negative 14/4 plus 9/4, so negative 5/4. So now I'm going to take the square root, getting to the square root property. This is going to be x plus 3 halves equals plus or minus the square root of negative 5/4. Now, this square root of a fraction, this can always be simplified. When you're taking the square root of something that's being divided, you can take the square root of both of them separately. You can also do that with multiplication, but not addition or subtraction. On top there, I've got a negative, right? So I'm going to need to pull out an I. And on the bottom, the square root of 4 is just plain 2. So now I'm going to solve for x by moving the 3 halves to the other side. And if I wanted to put this into one fraction, I'm adding and subtracting, so we need a common denominator. I already have it, so I can literally just add and subtract the numerators. and then these would be my two answers. Now, this is fine, this is also fine. I like getting it into the second form though, because it looks like what you would get if you solved this with the quadratic formula. In fact, there's a direct connection between completing the square and the quadratic formula, and we're going to talk about that next.